Hi everybody, it's Mrs. Dunn. We're starting to learn about complex numbers today. Specifically, what I want you to learn from this screencast is how to add, subtract, multiply, and divide complex numbers, how to simplify a radical using the definition of I, and how to find the powers of I. This screencast, there's a lot going on, so I'm probably going to do this in a few sections. I'll see how long this screencast goes, but I'll probably do this in at least 2, maybe 3 parts. Okay, so to begin with, what we need to do is define I. So the definition of I is going to be equal to the square root of -1. Now remember, up to this point, when we went to find the square root of -1, we said that was undefined. And today what we're doing is we're defining that. And we're defining that as the number I, which is an imaginary number. Now, if I is equal to the square root of -1, then it follows that I squared, by definition, has to be equal to -1. So the square root of -1 times the square root of -1, which would be I squared, is going to also be equal to -1. Okay. So now that we've defined I as the square root of -1, we're going to express each one of these numbers in terms of I. So think about these 4 questions: the square root of -4, square root of -21, square root of -98, and negative square root of -28. Let me show you how you should be thinking about these problems. So the square root of -4, we're going to separate that into the square root of -1 times the square root of 4. Now, what's the square root of -1 equal to? I. And what's the square root of 4 equal to? That would be 2. So the square root of -4 is I times 2, which is 2I. Okay, look at letter B, the square root of -21. The square root of -21 is the square root of -1 times the square root of 21, which is I times the square root of 21. Now, you can't break down the square root of 21 any further than that, right? Because the square root of 21 is 3 times 7, and neither of those are square numbers. But when you look at the square root of -98, there's a square number that divides into 98. That's the number 49. So I broke this one up into the square root of -1 times the square root of 49 times the square root of 2. Now the square root of -1 is I, the square root of 49 is 7, and the square root of 2 is equal to the square root of 2. Simplified, that's 7I times the square root of 2. Okay, last one. So square root of -28. Now, once again, I'm separating the square root of -28 into the square root of -1 times the square root of 4 times the square root of 7. The square root of -1 is I, the square root of 4 is 2, and the square root of 7 can't be simplified. It's just the square root of 7. So our final answer is -2I times the square root of 7. Okay, -2I times the square root of 7. All right, the next thing we want to do is talk about complex numbers. So now that we know what imaginary numbers are, now we're going to talk about complex numbers. Here's the definition. Basically what this is saying is we're going to have a real number part and an imaginary part. So here are some examples. Like 5 plus 6I, the real number part is 5, the imaginary part 6I. -4 plus 2I, 7 minus I, all examples of complex numbers. So now what we're going to do is add and subtract them. So if we're going to add or subtract, for example, 8 plus 4I plus 2 minus 7I, I bet you intuitively know what to do. So if you were thinking, I'm going to add the real number parts, 8 plus 2, and the imaginary parts, 4i plus negative 7i, then you were exactly right. And so that answer should be 10 minus 3i. 8 plus 2 and 4i minus 7i is negative 3i. All right, see if you can do this one. Now don't forget, if we're subtracting, we're going to have to distribute that negative sign. So it should be negative 2 plus 5i minus 4 plus 3i. Now remember, combine the real number parts, combine the imaginary parts. So you should have gotten negative 2 minus 4 and 5i plus 3i, which is negative 6 plus 8i. Okay, I think I'll stop here and I'll do multiplication, division, and powers of I on the next screencast.